Okay, so we are trying to find vertical asymptote of a function. Let's first start with the definition of the vertical. Oops. Definition of vertical asymptote. So a vertical line. Remember the vertical line, the equation for vertical lines are x equal to a number. Is a vertical asymptote of a function f of x if this happens when you approach to a f of x goes to either plus infinity or minus infinity. Well, indeed, it is just enough that instead of approaching to a from the whole thing, it's enough to approach to a from either right or left. The important thing here is that how to find that a. So if you have the rational function, the denominator of that guy is the so to find a, we use the candidates that, well, if it is a first case is that if it is some function over another function, the roots of the denominator is a case, are a candidate, then you have to practice this kind of work. And also, if you have ln of something, ln of expression, then roots of that expression. So you find those ones and then try those ones and see which one works. So for example, in our case, so back to my example, f of x is ln of x squared minus 1 plus x. Oh, this is supposed to be x squared. So x squared plus 5x plus 6 over x squared minus 4. I actually have two things here. I have both ln and I have a quotient. So first, roots of the denominator. From there, you see that x is either plus 2 or x is negative 2. Also, inside the ln, find those ones. And that will be x is either 1 or x is negative. So now I have 4 candidates. I have to work with these 4 candidates and try to see if any of those will give me plus infinity or minus infinity. So this guy, that guy, that guy, and that guy. In other words, one by one, we have to try. So for x equal to 2. So I try limit of function as x approaches to 2. And this is, well, I know that ln of x plus 1 minus 1 has limit there, and limit of x4 plus 5x plus 6 over x squared minus 4 as x approaches to 2. The limit of the first part, ln of x squared minus 2, this is ln of 2 squared minus 1. And for the second one, when you look at this limit, just this limit itself, you notice that, okay, limit of x squared plus 5x plus 6 as over x squared minus 4, as x goes to 2, this guy in the numerator, actually, this is very nice. Oh, okay. I don't need to separate that one. I can do it right here. This guy is um, in the numerator, I get 4 plus 10 plus 6. This is 20 over denominator. It's going to be either plus or minus infinity. Yes. For the asymptote, vertical asymptote, I don't need to see exactly where it is positive or negative. I know that non-zero number over 0, it's either plus or minus infinity. So I will have either plus or minus infinity here. This number here is ln of 3 plus or minus infinity. Well, you have ln 3, which is just a number. You add very big numbers, the numbers which are growing big and big. So you will get plus infinity, or you subtract, you get minus. As x goes to 2, the function has infinite limits. So that means that x equal to 2 is a vertical asymptote. How about x equal to negative 2? Well, limit of x goes to negative 2 f of x is limit of ln of x squared minus 1 as x goes to negative 2 plus limit of x squared plus 5x plus 6 over x squared minus 4 as x goes to negative 2. Well, the first part, as we had before, this is ln of 3 plus. The second part, when you try to find the limit of that, as x goes to negative 2, you see that it is going to be 0 over 0. 0 over 0, I can factor out these guys. This will be x minus 2, x plus 2, and this will be x minus 2, x plus 2, and x plus 3 as x goes to negative 2. These two cancel, and then limit of x plus 3 in the numerator is negative 2 plus 3, and negative 2 minus 2. This is 1 over negative 4. So the limit of the second one is 1 over negative 4. And that is just a number. It is not a vertical asymptote. So that is the conclusion we get. X equal to negative 2 is not a vertical asymptote. Oh, this is getting long. So for x equal to 1, one thing that you have to notice is that x can only approach to 1 from the right for numbers bigger than 1. Otherwise, we are going to have ln of a negative number, which we are not allowed to have. Ln of negative number we are not allowed to have. So this will be ln of x squared minus 1 plus this guy, limit of x squared plus 5x plus 6 over x squared minus 4 as x goes to 1 plus. Well, this part here, as x goes to 1 plus, x squared minus 1 gets smaller and smaller number. And this will be the same thing as, I'm going to use box again, ln of box times x squared plus. So this will be 0 positive numbers. Remember that ln of x, as x goes to 0 plus, it is going to be negative infinity. And the second part here, this is going to be just a good number. 1 plus 5 plus 6 over 1 minus 4. This is going to be negative infinity first part. The second part is 12 over minus 3, which is minus 4. A big negative number minus 4, it is again big negative number. So that means that y equals to 1 is a vertical asymptote. And for x equal to negative 1, well, this time you have to find limit of x approaching to negative 1 from the negative side of ln of x squared minus 1 plus x squared plus 5x plus 6 over x squared minus 4. And you will see that the same argument will work there plus some number. This will be negative infinity. So that is another vertical asymptote for f.